So here we're going to talk about compact inequalities, compact compound inequalities. Now, different textbooks use different terminology and stuff. We've sort of seen this before, where we had something like x is greater than 2.5 and less than 4. Really, if you read it from left to right, you're going 2.5 is less than x is less than 4. Something like that. You know, and we talked about what that looks like on a number line, 1, 2, 3, 4, and we were saying, oh, it's between 2.5 and 4. I didn't put the equal to part, and it was all those numbers in between. It's kind of that in-between situation. So it's written in a compact form. It's actually saying two things. It's saying x is greater than 2.5, and also x is less than 4. So that's why we call it sometimes a compact compound inequality. It's two statements in one, 2 for the price of 1. Okay, so the great thing about this form, though, is they're fairly easy to solve. So here's an example. We have -3 is less than 2x plus 1 is less than 3. So you'll notice your variable is in the middle part, right? So we still want to get x by itself. We still want to solve, but there are 3 parts. Normally, like in an inequality, we just have the left-hand side and the right-hand side. Or in an equation, you have the left-hand side and the right-hand side. But now we have like 3 sections. I think of it as the hockey game in math, because hockey is the only sport I know of that's played in 3 periods. You know, usually it's like 2 halves, right? Like soccer is, and basketball, 2 halves, right? But hockey, there's 3 separate periods. Okay. Anyway, a little lesson on hockey there. What we do is we're going to solve the inequality, but we're going to solve all 3 sections at the same time. So we're going to subtract 1 to get x by itself. So we're going to subtract 1 here and 1 here. And we can just do all 3 sections at the same time. So I get -4 is less than 2x is less than 2. Yeah. Trying to think if I missed anything. Okay, now I'm going to divide by 2. I'll divide by 2 on all 3 sections. So I get -2 is less than x is less than 1. Now they want me to solve and graph it on a number line. If I graph it on a number line, it's going to look like this. Here's -2 and here's 1. And we have just less thans, so parenthesis, it's all the numbers between -2 and 1. In interval notation, it looks just like that, -2, comma 1, parenthesis. In set builder notation, if you really want to do the set builder notation, x is less than, and then I'm just going to recopy this. -2 is less than x is less than 1. Okay, there you go.